Welcome back to HANA Basics for Developers. In this unit, we're going to take a closer look at object-oriented JavaScript. Now, this is something that hasn't always gone so well together. A lot of people tried to apply object-oriented constructs using the JavaScript object, and you might think, well, that sounds like it would work, right? But as we saw earlier when we looked at the JavaScript basic syntax and features, is the JavaScript object isn't exactly what lends itself to object-oriented concepts. It has some of those concepts, but it doesn't have a true class kind of structure, doesn't have public and private parts really, doesn't really have clear inheritance. Yes, people over the years found interesting ways to get close to some of that functionality, but I kind of look at that as an abuse of what the JavaScript object was actually intended for, and far better now to use the true object-oriented concepts that we have in JavaScript, because since ES6, ECMA scripting version 6, the JavaScript language has a true class construct, and with it comes traditional object-oriented capabilities like the ability to have public and private parts, inheritance, constructors. And what I'd like to do in this video is take a closer look at doing object-oriented JavaScript and how you can take advantage of some of these features. So let's go back to our project, and in our routes folder, let's begin by creating a new route called tutorial1.js. And like everything else, we've got some snippets already created for us. 1.js. And let's have a look at this. All right, so this is a pretty simple example, in which case we're going to have a class, and this is I think one of the more useful constructs of how object-oriented is applied in JavaScript. We kind of merge the concept, the new concept of classes, true classes, with the existing concept of modules in Node.js. And what we're able to do here is basically directly export a class as the module export. And this basically allows us to use our class as our implementation method for our reusable modules, even when called via NPN, even when they're outside of our project. And increasingly, personally, I've started to do this. I think it's a clearer construct, a clearer reusability approach to use classes as the implementation method of your modules. And what we've done here is, yes, I export the class directly, and I have a constructor. So just like in other object-oriented languages, certainly once again drawing correlations to ABAP, you have a specialized method that gets called automatically when you create an instance of the class. So JavaScript has the concept of static classes and instance classes, as you would expect in object-oriented programming. This is going to be a very simple class called a constructor. We pass in some sort of ID into the constructor so that each instance can be identified. And we have the concept of this. So I've basically got an attribute of my class that I'm going to fill with the value that's being passed in to the constructor. Notice we don't have to pre-declare attributes like we do in some environments, like in ABAP. So we still take the very nature of JavaScript and its loosely bound variables and things like that, and bring those into the object-oriented implementation of JavaScript. Now we have an instance method here. My first method takes one importing parameter that I've called import1. I'm not getting very creative with my import names there, but I'm going to do a check on it, and if it's equal to the value 20, then I want to raise an error. So we see how we take the existing JavaScript concepts of being able to throw errors, and we've brought those into the object-oriented world here as well. So if you want to produce an error out of your method, you simply throw an error like you would in any other JavaScript concepts. Otherwise, we do a return, and that's going to be our exporting parameter out of our method. Pretty straightforward. Okay, let's create another file here. Let's call this one. Well, yeah, the way we want to test this, it's easier to do these one at a time and then test them all at the end, simply because of the construct of the code snippets that we're using here. So let's just go ahead and look at our second example. Let's get the code for that. All right, now we're going to get a little fancier here. I'm still going to take the class and make it my main export. But now let's look at static methods. So we're not going to create an instance of our class. We're just going to have reusable static methods. I always think this is like having functions, just a cleaner way of having functions. We could have potentially some inheritance here if we wanted to override. We'll see that later. So there are some advantages over using just plain JavaScript functions, but it acts very much like a standard function. And actually, when I'm converting, sometimes I'll take an existing module and I want to convert it to a class, and it's got functions in it. I'll just take it and make them static functions, so I don't have to rewrite a lot of the logic. It'll still act the same way. What you see here is I want to be able to get flight details. So inside here, I'm going to return promises. We still have all the concepts that we've seen with event callbacks, promises, async await. Those things don't go away in the object-oriented constructs. They work fine in here. In fact, we can apply async to a class method as well, just like we did earlier to a function. Any sort of event block inside of JavaScript, the async command can be applied to. So we're going to apply it to our static method here. That's fine. We're going to perform a database query. Just select star from sFlight, and we're going to pass in our input parameters here. We're going to parse them into the query, and then resolve that execution, so it will return the results. If there were any errors that occurred inside of here, we're going to catch them. We're going to create a custom error message, invalid flight. We're going to take the input parameters and pack them in there. We're going to take the details of the original error message that might have been thrown out of the lower level database library, and we're going to pass all that back as we reject. So that's going to be throwing our error back to the calling. Here we see where we can calculate the price. We're going to do the same sort of thing where we want to perform a database query, but then we're going to have some logic on the plain type and basically alter the price, different surcharges based upon the plain types, and then we're just going to resolve the price. A little bit later, when we consume these, we're going to see how maybe we take this static attribute, this static method, and embed it inside of a loop, or we're looping over a bunch of data, because we can do this one record at a time. Whereas maybe this is a mass retrieval of data. Pretty straightforward stuff there. All right, let's create another little tutorial here. Tutorial 3.js. Let's grab this. Now we're going to get a little fancier. So instead of our static functions, methods, we're going to do this as an instance-based class. This is more common. This means adjusting your calling logic. So it takes you away from the functional traditional approach of JavaScript. Now we're creating an instance of our class. We want to call this, we're going to have a constructor. In this case, all we're going to pass into the constructor is our database connection. And then you see what we're able to do here is we can store the database connection as an attribute in the instance of the class. Over here, each static method needed the database connection passed into it repeatedly. But here, we no longer have that in each of our instance methods. So get flight details and calculate flight price. We don't need the data to be passed in. We can persist it inside the instance of the class in memory. So we don't need the database connection. That makes things easier. But the same thing here. Once we've gotten the flight details, we can persist those as well. So this.flight. So once we've read all the flight details, we've got them here. And the same thing when we calculate the flight price, I don't need to pass in all the data from the previous call. It's stored as a attribute of the class instance, so I can directly process it here and then pass it back out. So more efficient. I'm not passing data back and forth as I would in the functional approach. I'm not having to keep track of which database connection I would use. If I was doing maybe multiple calls in parallel, I can really let the inner workings of the class persist and connect that for me. And you'll see in a minute, I can have multiple instances of this class and work with them in parallel. I don't have to worry about keeping the connection straight or anything like that. It's really kind of simplifies your code, particularly if you're already comfortable with object-oriented constructs. Now let's create another example here. So tutorial 4.js, and now we're going to see the real power of object-oriented. I mean, being able to have instances of your classes, certainly that's baseline object orientation, but you can see here we can also do inheritance. And this is where I think object-oriented gets really cool, so powerful. We get extension capabilities, the possibility SAP could write a basic class, and then you could come in and override that class, add your own customer logic to it without altering the original object. So what we're going to do here is I just got to require, just like a Node.js module, require the original class. That's how we can get access to the class, since I'm exporting it as the implementation of my module. So this class could be coming from NPN, from the outside world. It could be local to my project. It doesn't matter. In this case, it is local to my project, but I could just as easily gotten this from NPN, maintained it in my package JSON. But what we want to do here is just say, declare a new class as the implementation of this module, which extends the class Tutorial 3. So the one that is exported here, this class, we are extending it. So we'll have a constructor, concepts of inheritance. This should look very familiar, whether you're coming from Java, C++, or ABAP. Inside the constructor, you always must call the super constructor. That ensures that through the inheritance chain, all the constructor versions are operated upon. We don't have to redeclare the this.db. It's going to be processed within the super. But what we have here is calculate flight price. We're overriding it. So the original calculate flight price we have there, and basically we're going to say execute the super calculate flight price. So all the logic that's in there will be executed. We'll get the result back. Then we're going to add an additional 25% surcharge on top of it, and that's what we're going to return out of our overridden method. So without altering the original code, without necessarily even needing access to the original source code, we could have just required it from NPN. We can inherit, reuse, and override, redefine the original implementation. Key to object-oriented constructs, key to the value of such constructs, but so easy to do here. And like I said, I love the fact that we can tie this into what we already know about Node.js modules and have reusable Node.js modules that are our class definitions and share across systems, cross over the internet, all kinds of things. So super powerful construct. So now we need to consume these OO examples. So let's come here to our index. Let's add another route handler here. So app use node OO. require routes 00. There we go. Here's our route handler. Let's add a new route implementation here. So this is going to be our oo.js. And what we have, we've prepared this as a snippet as well. Now we're just going to call this one oo.js. And let's look at this code. So what we need to do is we need to require each of our other modules. So tutorial 1, 2, 3, and 4. And then what we see here is the first example, tutorial 1, where we just have a simple constructor and simple method. Oh, shoot, I did not mean to close that, sorry. What we want to do here is we create a new instance of that class. We pass in the value as we create the new instance. That's because the constructor is called automatically when we use the new keyword against the class. That gives an instance of our class, and we're able to call the method. In this case, I'm just inlining the call to the method of that class inside the output here. So we're going to pass that value back out. This is real simple what we were doing here. We were just taking the input value, and if it's not 20, then we return it. So in this first example, we should see the 5 coming back. We want to see what it's like to catch errors. In this case, we'll do the same thing, but we'll pass in the value 20. That will trigger our error condition. So then we need a try catch block to catch that error. And we'll take the error, we'll stringify it, and we'll output it so we can see what that looks like. So why don't we go ahead and run that one. We'll test these one at a time and have a look at them here. Let's see what that has for us. We'll run that. Oh, I have an error somewhere in my OO tutorial 4. Oh, where did I put that? Oh, I put it in the wrong folder. Common mistake. Easy to do. Let's just cut that and paste it. There we are. That looks good now. Let's try running that again. Pardon me. There we are. Now it's good. Let's test via our web module. Sorry. Node 00. And we want to look at our simple class example. To begin with, there we are. It returned the value 5 as we would expect it. And if we want to see what our error message, what our error object looks like, there we are, our custom message, call and catch errors, message something bad happened, and we have the value 20. And we get all that extra information because we packed in an error message, the original input value. So you can see how you can build custom errors. You decide what attributes you want in the error. The error itself is an object here. We pack the input parameter in there. It doesn't happen automatically, but it's a good idea if you have an error that's occurred. Someone who's catching it, you may want to let them know what values you had. Maybe if you calculated something inside here, maybe pass that in as well. Whatever can help in the troubleshooting of that error. Okay. Now moving on to example 2. This is the static example. So here we call the get flight details. We have to pass in the database connection, and here we have our keys to one of the records. And then we can call the, and we just take the results and pass them in the output. Okay, and the same thing here. We're going to calculate the flight price. We have to pass in the details because we're going to have to query it from the database. There's no carryover. They're static methods, so we need to always repeat the database connection and all the input parameters. Very much like if you had 2 different functions in JavaScript, you're always you're having to persist the data between the function calls and repass everything in. So it works very much like static methods work very much like traditional functional JavaScript, which can make it easy to convert to classes, but you're not really taking full advantage of the power of object-oriented there. So if we were to run this example, so if we run our static method, the first results, yes, we're getting back our record that matches the keys that we passed in, and the same thing with the static method here. Our calculated price $462. So we took our original price of $422 and we applied our little calculated upcharge, and there we see it there. Okay. Not terribly exciting because we're not straying too far from what we already know with functions, but now let's see the far more interesting instance-based example. In this case, we create a new instance of our class. We pass in our database connection, and then when we call the method getFlightDetails, we don't have to repass in the database connection, and we'll get the results back. But even better, the second example here, we create an instance of our class. We get the flight details. We don't even do anything with that. We don't even receive that back in our calling program. It's just being persisted as an attribute of the class instance. And now we can call the calculate flight price. We don't have to pass anything into it. We don't have to worry about passing the same query parameters into it that we did in the earlier example. It's all persisted in the instance. We just say calculate flight price. We get the results back, and then we can output them. All right, so let's have a look at the test of each of these. So of course the output's going to look pretty similar. We're bringing back the list of data, the one record. That's pretty straightforward. But now the more interesting example, we're outputting the calculated price here, even though, as you saw in our code, when we call the flight price, we're not passing any input parameters into it. It's all persisted in the instance of the class. All right. Last example, this is going to be our inherited example. And what you see here is it doesn't look any different. Okay, we still have the get flight details, even though we didn't do anything with that. We inherited from tutorial 3. We did not redefine get flight details, so we're going with the original version. So you don't need to repeat anything in the inheritance. We're going to get that get flight details from the original class, even though we're now referencing tutorial 4. But at the same time, when we call the calculate flight price, we're going to get the inherited and overridden version of the method. So let's have a look at it. So of course, when we call the inherited method, it's going to give us the exact same results as the original method. No difference there. Flight price 42294, 42294. But now when I call the overridden inherited method, what we see here is a calculated price of 578, and of course when we called it originally 462. So same base method, but now we're applying the additional surcharge, the upcharge that came through our inherited method. So you see the power of that. I accessed the original calculation without even knowing what it was doing, without having to have the access to the source code. I'm reusing it. I'm overriding it. I'm actually changing the calculation, but without having to go in and change any of the original source code. Now I know this is really just very much a beginner's guide to object-oriented. There's so much more power that can be used in object-oriented constructs. And of course, what we've seen here, inheritance, constructors, redefinition, public, private, static, instance, these are core object-oriented constructs, not specific to the JavaScript environment. I hope many of you, if you're coming from the ABAP environment, these are things that you know from there, and you see how you can bring that same power and utilize it in the JavaScript environment now as well.